A very good morning to everyone, dear 10th standard students. In previous class, as we have discussed about the electromagnetic induction, in that we have discussed mainly about electric motor and generator and Fleming's left hand rule, thumb rule, and Fleming's right hand rule. And we have discussed over the Faraday's experiment how exactly the current is produced, and some of the very important questions also we have discussed. Children, let's start. Yeah, before that, I have sent a PDF of electromagnetic induction chapter. That's kindly write neatly in your notes and show me on Saturday, on open day. Fine. Okay, so in today's class, let's try to start a new chapter which is called carbon and its compounds. Okay, so it is in your textbook. It is in second part, first chapter, second part of the textbook in the first chapter. As far as first part is concerned, we have this come across all the chapters which are related to the physics and chemistry. And as far as chemistry is concerned, the next chapter in the second part of the textbook is carbon and its compounds. Children, before starting this chapter, let me tell you something about this. And which is here in this chapter, we mainly deals with the compounds which are related to the carbon, and kindly write down there. So I told you many times, so while you are listening to my lectures, so kindly keep handy the textbook, use headphones for a better audio quality, and kindly use the pencil so that you can mark the questions or write important things, and kindly keep a keynote handy so that you can write important points. Okay, fine. So let's start a chapter with the carbon and its compounds. Before, let me tell you something. In this chapter, we are going to mainly deals with the compounds which has carbon, which chemically we can symbolize it by the C, right? Carbon and its compounds. Okay. So children, let me tell you something. You can write a keynote there. These carbon compounds we also called as organic compounds. I repeat, these carbon compounds we also called as organic compounds. It does mean that the compound which deals with the carbon are called organic compounds. Means, in short, I can tell you the compounds which consist of carbon in it, let it be other elements also, but there should be a carbon present in that. After finishing up your SSLC, next in PUC you study organic chemistry as a separate, and in degree if you take a CPZ or something, if you study chemistry there, they're completely for 100 marks for each year you study only the organic compounds separate. So such a vast compounds. So remember that in a day-to-day life we use many chemicals, right? Many compounds we use. In those compounds, many is most of more than 90%, I can say that. Okay, more than 90% of compounds which are comprises of carbon. Okay, it does mean that the compounds which deals with the carbon are called carbon compounds are called organic compounds, right? Organic, remember this. Okay, you may get in a MCQ question, that is this question as a MCQ question. Means the compounds which are deals with the carbon are called usually are called organic compounds. Okay, let's try to understand this chapter. Let's try to see what is given in your textbook, right? So here you can see in last chapter, means in it is not related to you, just leave it off, and just we'll see. We come to know many compounds are important to us, isn't it? There are many compounds which are important to us because we use these compounds in our day-to-day life. In this chapter, we will studying about some of the interesting compounds and their properties. Also, we shall be learning about carbon, an element which is immense significance, means huge. It is immense means huge, large ಅಂತ ಹೇಳ್ಬೋದು ನಾವು ಹೌದಾ. immense significance to us in the both its elemental form and in a combined form. Elemental form means it in separate form, right? Means in isolated form, and also in a combined form. For example, carbon dioxide CO2, okay, carbon monoxide CO, okay, HCl HCl hydrochloric acid, right? See all this, many, there are many more, okay, you cannot count them. So there are so many compounds are there, so which consist of carbon in it, whether it's in a isolated form or in a combined form, okay. So all these compounds, okay, we come across many compounds in day-to-day life. There's a small activity given, let's try to see. It's very simple. Make a list of things you have used to consume since in the morning, okay. So from morning to evening, what the things we use, just to list them. In that, compile this with the made by your classmates and then sort out it items in the following table, okay. Following table you have to sort it: things made of metal, things made of glass or clay, non-metals, and others, okay. In that, you can able to observe so many, most of the compounds which are in which the carbon is, it comprises of a carbon, we can able to see that. Okay, let it be. Look at the items that come in the last column. Your teacher will be able to tell you the most of them are made up of compounds of carbon, isn't it? So most of the compounds that we use in our day-to-day life are comprises of carbon, means consist of carbon in it, okay, in a combined form. Can you think of method of test this? What would be the product of if compound containing carbon is burnt? Do you know of any of this does come from this? Okay, let's try to understand that. Food, clothes, medicines, books, isn't it? These all things we use in our day-to-day life, or many of the other things that you listed are all based on this versatile, means huge and the versatile element carbon. In addition, all versatile in other sense also, we can say that it is a sudden reacting element ಅಂತ versatile nature ಅಂತ ಹೇಳ್ತೀವಲ್ಲ. So all living structures are carbon based, okay. The amount of carbon present in the earth crust and in the atmosphere is quite meager, means is quite small. The carbon which consists, you know that nitrogen is a compound which is consist hugely in the atmosphere, and the second one is the oxygen, okay. But carbon dioxide very meager, it is meager means very small, right there. If you don't know the word, synonym of the meager is very small anta, okay. The earth crust has only 0.02% of carbon in this, in the form of minerals like carbonates, hydrogen carbonates, coal and petroleum, okay. Now you can able to understand that coal and petroleum also, and all the products related to the coal and petroleum, like it may be the plastic, or it may be the detergent, or it may be the, you know, many wax, paraffin wax, and all other polish, and all other compounds which are based on the hydrocarbons, means which are based on the petroleum, are all compounds of carbon, right? The amount of carbon present in the earth crust and the atmosphere quite meager, right? Very small. The earth crust has only 0.02%. This also you remember, so that you can able to understand that MCQ questions you may get it. So what is the next question? Here we are discussing. Second question is the amount of carbon present in the atmosphere is 0.02%. Remember this, okay. So next, carbon in the form of minerals like carbonates, hydrogen carbonates, and coal and petroleum, and the atmosphere has 0.03% of carbon dioxide. Remember, 0.02% of total carbon present in the atmosphere, in which is 0.03% of carbon dioxide. I hope you are getting it. Okay, 0.02% of total carbon in the atmosphere, in which is 0.03% of carbon dioxide, right? In spite of this small amount of carbon available in the nature, The importance of the carbon seem to be immense, means it is huge importance, because without carbon we cannot imagine our life, means it's very important. In this chapter we will looking at the properties of the carbon which lead to this anatomy, sorry, anomaly, right, means which leads to this anomaly, means this process on the, okay. So next, bonding in carbon, the covalent bond. So remember that the carbon atoms links together, okay, the carbon atoms links together in the they through the bond, okay. We might have studied in ninth standard. I hope you have studied this, because ninth standard I have not taken the chemistry. The carbon atom links to the carbon atom, right, through the process called chain, through the chain process. So this, through a bond, we call it as bond, the combination. For example, I can tell you here, look at children here, for example, there's a carbon, and okay, there's one more carbon atom here, here one more carbon atom, okay, here one more carbon atom. So these carbon atoms are links together with the bond, right, links together with the bond. So this bond is called a covalent bond, covalent bond, right. In this in the previous chapter we studied the properties of ionic compounds. We saw that ionic compounds have the high melting and boiling points and conduct electricity in the solution or in the molten state. So ionic compounds, which are the properties of ionic compounds, which are high melting point, means they have high melting point, means they melts to the very high melting point, and boiling point is high, and they conducts the electricity, okay. Saw how the nature of the bonding in the ionic compounds explains these properties. Let us study the properties of some carbon compounds. uh, Melting and boiling points of some carbon compounds are given in the table, okay. Here in the table, let's try to understand the table here. Look at here, compound. Look at here, as I told you just now, if in there's a compound, okay, if any one carbon atom is there, means these are called the carbon compounds, right. So here you can see that acetic acid CH3COH, in that melting point of acetic acid is 290 Kelvin, boiling point is 391, right. Chloroform CHCl3, which has 209, 334 respectively. Ethanol CH3CH2OH and 156, 351. Methane CH4, which is 90 and 111, right, boiling point. Got it. So you can see that according to this table, most of the carbon compounds are poor conductor of electricity, as we have seen in the chapter. From the data on the boiling and melting point of the above compounds, we can conclude that the forces of attraction between these molecules are not very strong, since these compounds are largely non-conductors of electricity. We conclude that the boiling in these compounds does not give rise to any ions, right. In class 9 we learnt about the combining capacity of various elements and how it depends on the number of valence electrons, okay. So valence electrons, so remember that. One more important thing I'll tell you, what do you mean by the valence electrons? You might have studied in the ninth standard, but for your kind information, I'll tell you once again. Valence electrons means the electrons which are present in the outermost shell, okay. The electrons which are present in the outermost shell are called the valence electron. So now I'll tell you very important thing. Try to understand, children. It's very important. It's the basic. You have to understand it. So I can tell you that. Look at here. For example, carbon has an atomic number 6. Okay, C6. Right. Carbon has atomic number C, which has 6. Right. Yeah, dear students, as I discussed it just now, that is carbon, which is has atomic number 6. I was discussing about the what do you mean by the um, valence electrons, right? So let's try to understand meaning of the valence electrons. So, dear children, valence electrons means the electrons in the outermost shell. Kindly write down if you don't know. The electrons which are in outermost shell are called the valence electrons. Who exactly it will be? Let's try to understand that. Okay, look at here. Let me tell you some basics. So here you can see that, for example, carbon C, which has atomic number 6, right? Atomic number 6. Okay, remember, you have to remember this atomic numbers, which has atomic number 6, in which children, for example, there's a nucleus at the center, right? Nucleus at the center, and suppose this is the nucleus, which consists of protons and neutrons, and it got a shells. This got the first shell, right? And this is got the second shell, and this is got the third shell, right? Let it be. Cannot draw very clearly here. This is called the third shell, and this shell is called from inside. We'll mark them. This is K shell, and this is L shell. This is M shell, right? Look at here. Now we can mark the electrons in that. Look at here. So carbon has got 6. So always children remember that we have discussed, I think, in the previous class of it, the previous chapters, that is which has a first shell has 2 electrons, right? One, which is 2 electrons, and second shell also got has affinity of electrons is 8 here. So here the remaining electrons are 6, right? So 2 1 2 3 4. Okay, affinity of electrons is 8, but it has got only 4 electrons in the outermost shell. So valence electrons for the carbon got has valence electrons as 4, right? 4 valence electrons. Why 4 electrons valence electrons? Because in the outermost shell there are 4 electrons which are present in the carbon. Okay, so look at here. So let's try to understand. We have learned about the combining capacity of the various elements and how depends upon the configuration of the numbers of valence electrons. How it depends on the valence electrons. And one more thing about the valence electron definition is, simply we can say that the electrons present in the outermost shells, okay, not only carbon, in all the elements, outermost shells are called the valence electron. First thing. Second thing is, the valence electrons are responsible for sharing the electrons between two elements, right? For example, there's a carbon. I'll tell you how it is. For example, there's a, again I'll take the example of carbon. Suppose there's an element carbon, okay, and one more element, there's a carbon, right? Two element carbon element are there. So in which in outermost shell there are 4 electrons, right? 4 electrons in the outermost shell. Just now I told you 4 electrons, and here I can also draw the 4 electrons, uh, 4 electrons which are in the outermost shell, right? So these electrons are covalence electrons. Here there are 2 elements, right? Actually there are 2 elements of carbon, in which these outermost electrons are combined to each other, right? Combined to each other, so that to form a covalent bond between them, right? Covalent bond between them. How it will be? So it will be like this. Suppose the covalent bond between them, for example, carbon attaches to the carbon through the outermost electron, so it becomes C2. It becomes C2, right? It becomes C2, right? So in the sense, these are responsible for sharing the electrons between them. Okay, so in your textbook it is given the atomic number of the carbon is 6, right? So what would be the distribution of electrons in the various shells of the carbon? So I just told you this is just now. We have discussed in the outermost shell of the carbon there are 4 electrons which are called as valence electrons, right? Kindly write there. These are called as valence electrons which are in the outermost shell, and these electrons are responsible for sharing the so combining the elements, right? Combining the elements by sharing the outermost electrons. We know that reactivity of element is explained as their tendency to attain a completely filled outer shell, that is, attain a noble gas configuration elements forming ionic compounds achieved by this either by gaining or losing the electrons in the outermost shell. We have discussed in previous classes. I hope you understand that. That is, we have discussed the nature of sodium chloride. Okay, sodium has 11 and chlorine has got 17 outermost, total electrons. Sodium donates one and becomes okay positive and becomes sodium 10, and chlorine accepts one and become negative, and it becomes 18, right? So total element is called sodium and sodium chloride. There's a compound forms as a sodium chloride, right? So in which the noble gases also we have discussed. Okay, the elements which have the octet arrangements in their outermost shell. For example, the elements like noble gases. Look at it, noble gases. For example, suppose this is the first shell, this is the second shell. Okay, and here at the center there is a nucleus, right? In which suppose there are outermost electrons will be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, suppose 8 electrons. Here also I can draw 1, 2, 3, and 4, 5, 6, 7, and 8. Okay, in outermost shell there are 8 electrons. Then these are called octet structure. I told you mono means 1, di means 2, tri means 3, tetra means 4, penta means 5, hexa means 6, hepta means 7, octa means 8, nano means 9, deca means 10. Okay, so when octet arrangement, which are always usually called as a noble gases. Why these are called noble gases? Because these are called as a noble gases because they do not share the electrons when they get an octet structure. Remember that in the outermost shell, if there are 8 electrons, then it is called as a octet arrangements. When the elements have a octet arrangements, then they will not going to share any sort of electrons with the other elements, so they cannot form the compound. Okay, remember that when the elements have a octet arrangements in their outermost shell, means 8 electrons in the outermost shell, then they will not share these electrons with any other elements or compounds. So such elements are called noble gases. Usually these are noble gases. Attend, noble gases means in the outermost shell there will be 8 electrons exactly. Okay, so they do not form any covalent bond or any sort of bond with the any other element, right? We know that the reactivity of element is explained in their tendency to attain a completely filled outermost shell, that is attain a noble gas configuration. This arrangement is called configuration. Okay, the meaning of configuration is arrangement. Elements forming ionic compounds achieve these by either gaining or losing the electrons in the outermost shell, and this is formed by even by gaining or losing. For example, there are 7 electrons in outermost shell, then they accept one electron in order to become octet arrangement. Okay, so next um, it will go it were to gain or lose electrons, right, in order to become octet. For example, it could gain 4 electrons for forming 4 minus. Okay, gain means, I told you, gaining means negative, donating means positive. So it could gain 4 electrons forming C4 minus, isn't it? Athena, but it would be difficult to form a nucleus with the 6 protons to hold on to the 10 electrons, that is 4 extra electrons. Okay, so second point is given, it could lose 4 electrons and becomes 4 plus. So why 4 plus means it is donating means positive. I told you in the previous class, begging is a negative thing. Okay, and donating is a positive thing. So remember it in this way generally. Okay, fine, we have discussed it in previous class, I hope. And then it could lose the 4 electrons to form C4 plus, that is cation, right? Remember that cathode means we are discussing a metal chapter. cathode means negative, anode means positive, but cation means positive ion, anion means negative ion, right? But it would require a large amount of energy to remove 4 electrons, leaving behind a carbon with the 6 protons in its nucleus holding on the just 2 electrons. So what carbon will do? Let's try to understand it. Carbon overcome this problem by sharing this valence electrons with other atoms of carbon or with the atoms of their other elements. Not just carbon but many other elements form molecules by sharing electrons in this manner. Okay, they share electrons, as I told you, outermost electrons nothing but a valence electron shared by the other elements in order to form a compound. The shared electrons belong to the outermost shell of both of the atoms and lead to both atoms attaining the noble gas configuration. Before going to the compounds of carbon, let us look at some simple molecules formed by the sharing of valence electrons. Okay, so what are this? Let's try to understand that. Okay, look at here. The simplest molecule formed in this manner of that hydrogen, as we have learnt earlier, the atomic number of hydrogen is 1. You know that atomic number of hydrogen is 1. We know that. So hence hydrogen has only one electron in its outermost shell. Correct? Nothing but K shell, first shell. And it requires one more electron to fill in the K shell, because we have discussed in previous class, I hope, that is electrons always share in a stay in pairs. Okay, the pairs in the sense even number, not in odd number. So here hydrogen has only one, which is odd number, so one more it needed to become even. So two hydrogen atoms share their electrons to form one molecule of hydrogen, H2. This allows each hydrogen atom to attain the electronic configuration of a nearest noble gas, helium, which has 2 electrons in its K shell. Helium is He 2, right? We can depict this using dots or crosses to represent the valence electrons, as you can see in the picture there. You can see that a molecule of hydrogen which has 2 hydrogen electrons, right? 2 hydrogen electrons, molecule of hydrogen. The stable molecule of hydrogen is, we know that, H2, right? Stable is H2, we know that, isn't it? Stable is H2. So H2 in the sense there are 2 outermost electrons. How we can share these electrons? As you can see in the picture here. So here you can see the crosses instead of dots. We can denote it by dots, as well as we can denote it by the cross like this. Okay, we can denote it cross like this, as you can see here, children. So here you can see that 2 electrons of hydrogen combine together to form a stable state of a H2, right? In the same way, here also in the oxygen, oxygen has, look at here, oxygen which has got look at here, O2, we can say the oxygen has 6, okay, O2 molecule. So look at here, O2 in the sense here the cross, the here the for example we say in the mass, that is Venn diagram. So in the form of Venn diagram it is represented. In that also we can able to see that the crosses indicates the electrons, sharing of electrons. Here 1 2 3 4, 2 bonds are formed. So here you can see that because of forming of 2 bond, here one single bond is formed, because only 2 electrons is formed in that. So in the hydrogen, 1 minute I'll show you. In the hydrogen, change the color. Okay, fine. In the hydrogen, in case of hydrogen, only 2 electrons are responsible, right? So it makes a one single bond, H, right? But in case of, you can see here in the picture, sorry, here you can see in the picture, in case of oxygen there are 4 electrons are sharing. So 2 ಗೆ 1 ಬಾಂಡ್ ಆಯಿತು, 4 ಗೆ ಎಷ್ಟಾಗಬೇಕು, 2 ಬಾಂಡ್ ಆಗಬೇಕು. ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ oxygen 2 bonds are forms, right? 2 bonds like this, 2 bonds are forms, as you can see in the picture. In this picture you can able to see the 2 bonds are forms. And in case of look at here, in case of nitrogen, okay, in case of nitrogen there are 3 bond forms. 3 bond forms means nitrogen N, okay, N, and three bonds along with the another nitrogen. Okay, along with the another nitrogen there are three bond forms. So actually these bonds are between the two nitrogen atoms, triple bond. So this is called, very simple children, this is called one two electrons means single bond, four electrons means like this you can see the double bond, and three electrons means you can say the triple bond, right? You can see, you can observe the triple bond. Single bond example hydrogen, correct, H. Single bond, double bond example oxygen, we can say that, okay. And triple bond example you can say that nitrogen, N, correct. You can see that nitrogen N, which is an example of a triple bond, right? So molecules are arranged in this way, okay. The molecules are arranged in this way. So can you now depict the molecule of water showing the nature of the bonding between the one oxygen and two hydrogen atoms? So depict the molecule of water, H2O, H2O. So in which you know that molecule of water is consist of, the symbol is H2O, correct. You know that H2O, in that it consists of two hydrogen molecules and one oxygen molecules. If there is a one, we don't denote one. Remember this, I told you, we don't denote one there, right? So it is understood. So here H2O means, you can see that H2O means two hydrogen molecules along with the one oxygen molecule is it comprises of, right? So next, what would happen the case of a diatomic molecule of nitrogen? Nitrogen has the atomic number 7. What would be the its electronic configuration? Electronic configuration, how it comes? If the nitrogen means nitrogen 7 means it comes N7, N7, okay, 7. In the K shell, it consists of 2, correct? It is fixed. And KL shell, 7 minus 2 is 5. So in the L shell is consists of 5 electrons in the outermost orbit, nothing but in the valence electrons are 5 for the nitrogen. Nitrogen has the atomic number 7. What would be the electronic configuration and its combining capacity? In order to attain the octet, each nitrogen atom molecule has 5, means 5 plus 3 means 8, isn't it? It need 3 more extra. So when it becomes 3, take 3 more extra, it becomes octet arrangement, okay. So the nitrogen contributes 3 electrons to giving rise to these shared pairs of electrons. This is said to be constituted triple bond, right, between the two atoms, because triple bond means it has got 3 electrons, it except the 3 electrons. The electrons dot structure of N2 is shown in the figure, as you can see that, okay, which has got a, you can see here the picture clearly, you can see that N triple bond, 3 bonds, triple bond, N means nitrogen has got triple bond, okay. A molecule of ammonia has a formula, that is NH3. Can you draw the electronic structure of this molecule showing how all the 4 atoms achieve the noble gas configuration, okay, right? NH3, NH3 means N is 7, right, and H is 3, right? H is 3, as you can see that. One more thing, N has got 7, N has got N has got 7, that is equal to N is got 7, 7 means it becomes first shell 2 and second shell 5, okay. So outermost shell, how many electrons are present? Kindly see it very carefully so that you can able to understand it very clearly. So outermost orbit there are 5 electrons, right? So in order to become octet arrangement, how many electrons is needed? It needed 3 electrons. So in the outermost orbit, the nitrogen has 5 electrons. In order to become octet, it needs another plus 3 electrons, okay. So these 3 electrons it will take by the hydrogen. Hydrogen has a 1, okay. So H3 means 3 hydrogen, so it becomes in this way, it becomes, so it becomes nitrogen N, okay, and then 1 2 3, and this is, we can say that, we can also write like this H, okay, because 3 electrons of a hydrogen which are connected to the nitrogen, okay. So it completely, totally, we can call it as N N NH, okay, NH and a 3, okay, NH3. Got it. So N has got 5 electrons in the outermost orbit. Hydrogen has got only 1. So it is 3 is get connected. So 5 plus 3, 5 plus 5 plus 3, which is becomes 8. Okay, which is becomes 8, and which 8 is nothing but which is called as 8 is called as octet structure. Octet, right? 8 is called as octet structure. Got it? So children, in this way it's going to work. Okay, I think it's enough for today's class. In the next class we are going to discuss some more things. So this is your sir Sajid saying goodbye, take care, and kindly write the notes. The PDF I sent to you in the group. Kindly write the notes neatly and show me it on a Saturday. Okay, till then, take care. Bye bye.